The intent of this instructional video is to provide you with a comfortable working knowledge of cold process spray equipment in general and the maintenance issues normally associated with their use. A typical cold process spray system can be divided into 6 areas of major importance. Number 1, and perhaps most important to the system, is the displacement pump. This mechanical device is designed to produce vacuum, flow, and pressure. The power source that is used to drive the displacement pump is number 2. Commonly used power sources are the mechanical, pneumatic, and hydraulic systems. Third, and perhaps most overlooked, is the inline heater. This mechanical device's very important function is to add efficiency to the system by improving material viscosity. Changing the viscosity to a thinner, more fluid state allows longer lengths of hose to be used while still providing the correct amount of pressure needed for airless atomization. For modified mastics that contain a polymer, the inline heater becomes essential for maintaining the required 95 to 105 degrees at the point of spray application. Fourth is the delivery hose. Proper composition, size, length, and pressure rating play an important role in not only the safety of the system but also in the quality of the spray itself. Number 5 is the delivery gun. Operator safety and ease of operation are the main concerns regarding the spray gun. Number 6 is the spray orifice or tip. Material characteristics such as viscosity, fiber content, filler, and application rate will help us determine the correct tip size. When combined, these 6 major components make up the basic spray system. Here's how they interact with each other in order to perform at maximum efficiency. Sprayable cold process material is drawn from a container by the vacuum created in the displacement pump. Because the amount of developed vacuum is relatively low, emphasis must be placed on the efficiency of the suction assembly. Although okay for very thin materials, long, undersized siphon hoses normally found on equipment designed for paint spraying will starve a cold process pump and will result in very erratic spray performance. During cool weather, when material temperatures are less than favorable, these problems become much more prominent. You'll see here on the Hennes 4518X, the suction tube is submerged directly into a 55-gallon drum, allowing for the greatest amount of efficiency. On stationary containers, such as shown here on the Hennes 450-gallon reservoir, a full port 3-inch valve with 3-inch pipe connections are used to bring the material into the pump. Once inside the pump, force is applied through the repetitive action of the hydraulic motor. The amount of applied force will determine the displacement pump output pressure. Cold process materials that benefit from an increase in temperature are now delivered to the inline heating unit. Here the material is gently warmed to a pre-calibrated temperature as it travels through the heat exchanger. With the material at its correct temperature, it can now be transported to the spray location through the delivery hose. For each foot of hose attached to the system, a certain amount of pressure drop or line loss is realized. This is due in part to friction, which is created as the material passes against the hose's interior wall. The longer the delivery hose, the more severe the line loss becomes. When hose lengths exceed the pump's pressure capabilities, a loss of spray performance will occur. Other factors that add to line loss are hose diameter, material temperature, and material formulation. Starting and stopping material flow is the responsibility of the control gun. Most are trigger actuated with forced return to the off position. Airless spraying is like holding your thumb over the end of a garden hose. Your thumb helps to create a given amount of back pressure, and the size of the opening will determine how coarse or how fine the spray becomes. The spray tip serves the same function and will determine the pattern, coarseness, and volume of material being applied. Material formulation and rate of application will also be a factor in selecting the correct tip size.